For 25 through 28, they want us to use the definition of the logarithmic function to find x. So we're still transforming these ones. So if I transform number 25, I have 4 cubed is equal to x. So 4 cubed, this will be 64. So x is equal to 64. So that's kind of one of the advantages to being able to transform back and forth between logarithmic and exponential is sometimes it's better to have it in exponential to solve for x. Sometimes it's better to have it in logarithmic form to solve for x. For 26, if I transform it, then this will be 7 raised to x is equal to 1 over 49. Now this one we kind of have to look at it to solve for x. So to get from 7 to 49, you would have to square it. So I definitely need a 2, but it's not just a 49, it's 1 over 49, or it's 49 on the denominator. So in order to move it to the denominator, you would need a negative in the exponent, because negative exponents move it to the denominator if it's in the numerator to start out with. So this is kind of in two parts here. You need the negative to move it to the denominator, and you need the 2 to turn it into a 49. For 27, if I transform it, it'll be 9 raised to the x is equal to 3. And to get from 9 to 3, you actually need to take the square root. And square roots as exponents are fractions. So x raised to the 1/2 is going to get you 3, because raising a number to the 1/2 is equivalent to taking the square root of it. For 28, if I transform it, this is going to be x raised to the 4 is equal to 16. And then it's like what number raised to the 4th would get you 16, and in this case it would be 2. So a couple different types of problems here, but we really want to transform it on all of them to solve.